Alright, in this video we are continuing with section 8.7 which covers surface area, and we're going to look at finding the surface area of a hemisphere. So surface area can get tricky. It actually can be harder than volume, which we'll cover soon. When we start cutting a shape in half like a sphere to make a hemisphere, we do take surfaces away, but we're also adding surfaces. So let's go ahead and draw a hemisphere here. So I'm going to start with half of a circle. So this is half of my circle. Then I'm going to do my arc part here, and then my dotted part here, and I'll put in my radius. So you can see I'm missing the whole bottom half, but I also have this new circle on the bottom. So I'm going to have to take that into account. So even though I only have half of the outside, I only have the top half, I've added this circle because when I cut it, I made a new surface. Think about when you cut an orange in half, that circle that used to be on the inside, now that's on the outside, so that would have to be considered a surface. So for the surface area of a hemisphere, we know a sphere was 4 pi r squared, so now it's only going to be 2 pi r squared. But we have to add in that new circle that is now on the outside from the bottom, and that's just going to be another pi r squared. So we would get a total of 3 pi r squared. So I think that's kind of interesting that when the sphere was whole, the surface area was 4 pi r squared, and then when I cut it and I add that new surface on the outside, now it's 3 pi r squared. So if you remember, you can use this formula, 3 pi r squared, for the surface area of a hemisphere, and now it becomes a relatively easy problem. We've got the radius is 15 feet, so now the surface area is going to be 3 times pi times 15 squared, which is going to give us 675 pi feet squared. Again, this is an answer in terms of pi. If I wanted a decimal equivalent, it would be 2,120.6 feet squared. Alright, so get all your questions answered, and we'll see you next time.